Very good morning to you all. Let us start with today's session with the continuation of the previous classes. The previous classes we were in the discussion on the various what I call the cryogenic fluids and the important fluids and development of the cryogenic systems and history and development of the cryogenic as well the various physical and chemical and other properties of these cryogenic fluids like liquid oxygen, liquid hydrogen, liquid nitrogen, and liquid hydrogen. Very four important fluids were under discussion. We are discussing all those things. In connection with these fluids, another important topic related to these cryogenic fluids or cryogenics, the important topic is in the safety in cryogenics. So already we were in discussion on this. We are discussing on the properties. We were discussing about cooling, heating, and other thing, and the reaction, chemical reaction, and other thing. Whenever it is touching on the material, what will happen to the material surfaces whenever using this fluid and all that was already discussed. So, with respect to the case, we will be discussing on how to handle these fluids. What are the safety aspects? What are the different safety aspects in these cryogenic systems? That we are going to discuss in this topic under this topic. So that's the outline of the lectures are like introduction, the basic hazards and the causes, and how to protect that is this from the hazards. What are the hazards and how to protect it? So start with this introduction part of the safety in cryogenics. So as you know, the cryogens are nothing but the liquefied gases. So it was very well known to you. All the cryogenic fluids have been or can be produced from the process called as gas liquefaction. That is a process from which we are able to get the fluids. So they are called as cryogens or the liquid gases, which are stored or transported at very low temperatures. So extreme very low temperature or very frost temperature, very cold temperature fluids are cryogens or cryogenic fluids. They are formed from the liquefied liquefactions. So we are supposed to store it properly and we go to transport it properly at very extreme level. That is an important challenge. For during the challenge part, the safety is also very important as one of the important aspect of carrying or transporting or storing this handling these cryogenic fluids. So as I already known to us that whenever the materials are under the very low temperature, very extreme temperatures, their properties are become very brittle. They become brittle. So that is as we know. Similarly, there is a formation. There is the shrinkage. The shrinkage also occurs at the very low temperatures. That is causes a lot of failures and as well as cracks and leaks in the system of the area where we are using it. So wherever we are using cryogenic fluids, whether it may be in the storing or whether it is in the form of transportation part, that due to the reason of the brittleness property as well as the stringing property at low temperatures, there is a possibility of crack or formation of cracks or failures or leakages in the systems. Similarly, if it is there is a excessive boil off, that also causes some accidents due to the reason of sudden price level. Level in price pressure. Sudden rise in the pressure level. So sudden rise in the pressure level also lead to accidents because of the excessive boil offs. So these are all the very important aspects of the cryogenic fluids whenever it is on the storage or it may be in the form of the in the range of the transporting way of the fluids at the extreme low temperatures. So coming to these hazards, as I already mentioned, under this safety, we need to start with the various hazards and how to prevent it. So that and all is the very important thing. We'll be having to start with these basic hazards. So this extreme cold or low temperature hazard, that's the first hazard. Second one is the fire hazard. The third one, explosion. The fourth one, oxygen deficiency hazard, is also known as asphyxiation. And the next one is oxygen enrichment hazard. Another one is the material embrittlement. Sorry. So, with respect to the cold or low temperature hazard and fire hazard, explosion, deficiency, and enrichment, as well as the metal element. These are all the major hazards whenever these cryogenic fluids are in operations. So, we'll go and discuss one by one. The first hazard is extreme cold hazard. So, obviously, as you know, the cryogenic fluids are operating at extremely low temperature, maybe very, very cold temperature, or very, very low temperature system. Whenever these cryogens are exposed to, or we are using a bare skin, if we are using without any protective systems, or we are using a very bare skin operating conditions, the cryogens are cold vapors that emanating due to the continuous boil off. It causes some thermal bone injuries. With respect to temperature, very cold temperature, it causes the thermal bone injuries. That is the first hazard. So in certain range, time or certain cases or during certain period of time when the temperatures are very low, it is very low. The causes of injury, the causes of due to the thermal injury with respect to low temperature operation condition, the baskin kind of operation, that is very low operating system. Very for 5 seconds, the time required for this injury is very low. It is around the range of 5 seconds. Similarly, whenever we are inhaling the cold air or very low temperature vapor or very low temperature cold air, cryogenic fluids, that can directly damage lungs. So as well, not only lungs, it can damage eyes, can damage eye, skin, hand, feet, all whatever component is directly exposed to these fluids. They can directly spoiling or they can damaging the what they call the surface of the human body. That is therefore we got very important, very proper care has to be taken care during this handling of this or handling of these cryogenic fluids. Therefore, the skins, when not in protect case, then it can stick to the metal pipe that is cooled by a cryogen, as it is stick on the pipe. Similarly, when it pulled away, it tears the skin and adjacent tissues. That also happen when if it here to try to pull it away from the system of skins, the cryogenic fluid tends to tears the skin as well as it will use to tears the adjacent tissues along with the skins. So that is very important. This cold hazard, extreme cold hazard, direct and cold temperature affect directly on the bare skin of the while we are in the operating or handling these cryogenic fluids. That is one of the direct what I call extreme cold hazard, direct affecting the skins, tissues, eyes, hands, feet, and if you inhaling that fluid, cold fluid or cold vapor, it will also tends to what I call affect the lungs. And the time taken for the having the bone thermal bone injury is very low. Within 5 seconds, we can able to addict with this. We can attack with these thermal injuries. So these are all the case coming under the extreme cold hazards. Then next one is a fire hazard. So whenever we are dealing with these cryogen systems, for formation of the cryogenic fluids from the gases, the all liquefied gases, that the gases tends to like hydrogen or oxygen are very much flammable. So this will lead to a fire hazards. Whenever we go for liquid oxygen or we are going for liquid hydrogen, during this gasification process, the liquid gases like hydrogen, oxygen, they are very much inflammable. That causes the high risk for the high fire hazards. It is highly flammable or explosive sometimes. If it is air is present or oxygen is present in the right proportions during the rather than the air, it will also settle around the room as well as the laboratory full area and the ceiling and other systems. That is also one of the reason for fire hazards. So whenever the increase in the time, the gas volume accumulates not only in the room ceiling, it will accumulate all the corners and of the gases of every area. It will cause an explosion or causes fire hazards. So whatever there is a case, we should have some indication, like kind of thing, to avoid this kind of such a kind of fire hazards. Normally, we'll be having a flashing bulb or tubes or something like of blue light rotating blue light kind of systems, it will indicate the presence of more oxygen or flammable gases, which led to cause the fire hazards. So that is the second important aspects, safety aspect, hazards due to the presence of the gases like flammable gases like hydrogen, oxygen when react with the air or other thing. If the proper proportion is not in maintained properly, it will lead to fire hazards. The third one is the explosions. So normally, as you know, all the cryogen fluids or cryogenics will be stored in the cryogenic vessels. They are very closed containers. It will be insulated purpose. So because of this reason, sometimes there is a formation heat in leaks can occur. There is a continuous boil off can takes place. So what you will do if you don't provide adequate vent holes or vending on the system of the gases, there is a formation of the rise in the pressure. That pressure build up inside this container, that will lead to explosion. So in order to avoid this kind of explosion, the cryogen stored in a container or a closed vessel or closed container or like something called cryogenic vessels, if it is not properly vented, or holes are not provided properly, it will lead to build up a high pressure and leads to explosion. So that is another kind of safety hazards, which is called as explosion hazard. So the pressure also rise suddenly. It can rise with the presence of nitrogen and helium. So the reason behind that is these two fluids are having these fluid cryogens or cryogen gases are having very low latent heat of vaporization, and as well it having a huge expansion ratios. Gases to liquid expansion. That is the case. There is a sudden rise in the pressure. So that are also causes for the hazard known as explosion. This is another type of hazards, very modern hazards in this container or the cryogenic vessels. So sometimes some external fire or some break in the insulation vacuum system, or there may be a break in the vessels. They are lead to sudden pressurized causes tends to cause some explosion. This also lead to explosion case. So we are supposed to provide a pressure relief wall, or we can able to provide a bursting disc or diagram page or something, whatever we can mount it on the containers, so that we can relieve or controlling, or we can relieve or control the excessive pressure condition of the container. So as well, we can provide electronic alarms. So electronic alarms also used to alarm us or indicate us the pressure rise occurs whenever there is a rise in the pressure occurs because of this. The reason began that sudden pressure occurs and the ventilator contain closed containers. There whenever there is a vent line is choked, or when the valve is not function, or whenever the pressure relief valve is not function properly, the alarming can useful to have there is a sudden rise in the pressure occurs because of the condition of the vent hole is not available. So that is also one of the arrangements can be used to avoid explosion. Next one is oxygen deficiency. So we will be having two things. Oxygen enrichment also causes some hazards. Oxygen deficiency also causes some hazards. So let us start with the another hazard with oxygen deficiency. So there is just whenever we have all the gases are available with another gases in the atmosphere, so oxygen deficiency also occurs when the oxygen in the atmosphere is displaced with another gas. For an example, we need some amount of oxygen is required during this process, but instead of that, that amount of oxygen is replaced by another gas. Because of the reason there is the deficiency in the oxygen. That is the first that causes some hazards. That way, so oxygen is as you know, it is a colorless and odorless thing, very dangerous one. And without any warning, if we causes any explosion or any kind of fire hazards can occur. Similarly, the explosive of the normal causes is so in the order of 1:1000. Whenever we are boiling it, point to I mean condition atmosphere, the expansion is this stage. For an example, if you have 1 liter of nitrogen displays nearly 700 liters of air, that based on the percentage availability. So whenever the oxygen is deficient, that also causes some hazards. Whenever it is replaced by another gases, lead to some fire hazard or explosion. That is the second one known as oxygen deficiency hazard. So this causes the expansion ratio affecting and latent vaporization. Everything turns together, affecting the entire entire system of the uh, system where we are storing or we can handling the transporting this fluid. That is the second one. Next one. So whenever there is a deficiency in the oxygen, the gradient warms up little and it will boils off. So it is very low temperature when compared to ambient air. Similarly, what will happen? This nitrogen and argon, they are very heavier gases, but lower temperature gases. They displaces the air. Similarly, it displaces the oxygen. So this is more critical. So argon and neon, they are heavier than air. That causes some defects into the entire systems. So some of the nitrogen gases like hydrogen and helium, they will also mix with the surrounding air and stratify it. So that will also causes the deficiency of oxygen presence. So as I mentioned earlier, there will be a we want to provide ventilation or the opening or closed rooms if it is when the room is not unventilated or the container is a closed or tight container or the rooms are very closed rooms. This causes some defects as well as it displaces a large volume of oxygen displaced. So that causes some hazards to the systems. So similarly, the example given is that in a small laboratory room, we were using a Dever vessel. Dever vessel is a closed container. If it is not properly available with oxygen presence and other thing gases, it will lead to causes some sudden pressurizes because of the lighter or heavier lighter gases presence in displacement of oxygen. That tends to cause some variation in the pressure that will tends to have explosion or fire hazards. They are all called as oxygen deficiency hazard. Not only oxygen deficiency, oxygen enrichment also causes some hazards. So the temperature of the boil gases like helium, liquid nitrogen, and liquid hydrogen are very low enough to liquefy the surrounding gas. So this will always liquefied or the gases to become the liquid. So the liquid are solidified. That will what will happen? It will be settled down on the non-insulated cryogenic pipes. The insulation is not affected. Similarly, the latent heat of vaporization is nitrogen very small to that of oxygen. So if oxygen is more, so this also vaporization also causes. So this will go. This nitrogen will evaporates rapidly and condensing the air. But what will happen? The oxygen will be left in the rich component. It will be more. The availability of oxygen is more because of the appreciation of the nitrogen presence in the entire system of the air atmospheric condition of the fluids available in the system. So this oxygen enriched gases, with respect to which will be when will be reacting with a flammable material, it will cause us the fire hazards. So that is the case. So whenever the oxygen presence is more, also tends to cause fire hazards. So this is the reason behind that is that evaporation of this nitrogen, this the rate of nitrogen evaporation is very small compared to that of oxygen. Since oxygen is enriched, present is more, and this rate of evaporation is very small. That causes the reaction of the flammable material on which lead to fire hazards. So another one, last one hazard or which relates to concern the safety of the cryogenic fluid storing and transportation is material embrittlement. So as you know, almost all the materials used, or most of the material used in cryogenic applications have a crystalline structures. So as you know, phase under FCC, BCC, AC, and all simple cubic structure, phase under cubic structure, and bodies under cubic structures materials. So as you know, the FCC structure materials or remain, they will be always remain ductile at range temperatures, and BCC materials all becomes lower, little at lower temperatures. So in both the cases, both are operating with a low temperature regime of fluid called as cryogenic fluids or very extreme low temperature fluids. Because of that temperature case, FCC and BCC kind of material tends to have the material surface with the ductile and brittle in nature. So because that whenever the if it is there will be applying a load on the system of transporting the fluid or piping system, applying a small load that will tends to break down the structures. As well as the thermal stresses also developed whenever the materials are exposed to low temperatures. That is also a possible cases. So that will case because of the stresses and as well as the breaking the system. that will causes the materials embrittlement. So there is a possibility of rupture in the pipeline or breaking in the supporting column or whatever maybe that can causes because of the reason most of the fluid handling system or transporting system or piping systems made up of material they are in the form of in the nature of crystalline structure nature. That is also one of the important kind of property or hazards can occurring on the what I call the cryogenic fluid storing and transportations. So how to protect? So various hazards are like as we discussed, we have different hazards: oxygen enrichment, oxygen deficiency, material embrittlement, fire hazards, explosion, and there was something like we have different hazards due to various reasons with respect to the low temperatures and the material what we are using, how the supply system of braking system occurs, what are the stresses formation, everything due to the presence of the excessive pressure as well the causes reason behind that is what they call reacting with the surface bare body reaction, basket reaction with respect to the direct contact with these fluids and the piping kind of thing with the structural part of crystalline structures and presence of oxygen. Sorry, more amount of oxygen as well as less amount of oxygen also lead to some variation in the presence of other gases lead to if the enrichment amount is deficient, other bases will replace. That is causes some amount of variation in the pressure, lead to fire and other hazards. Whereas more amount of oxygen also tends to cause some breaking of the system. Other thing, we would to provide some proper ventilation or some safety measurement has to be taken into account. Whenever the materials are in the structure of crystalline structure, that will be the possible ductile and brittleness property that also causes rupture or breaking down of the piping systems and the supporting columns through which the materials are storing and transferring. So how to protect it? So normal protection from hazards are like they use the personal protective equipments as if normally we are using as the goggles. So eye protection is very important. So eye protection must be used whenever handling or transferring these cryogens. So we are providing a face shield or we can use safety goggles and we have to use it. That's a normal general principle we can follow. Similarly, gloves. So gloves are also one of the important safety parameter to protect from these hazards. So the trousers, the hands are to be protected with appropriate gloves, and you can use the hands and legs also covered with the gloves. They should be designed to prevent cryogen from flowing into the gloves. Some safety shoes. So it is mandatory to use high shoes, high top shoes while handling this liquid oxygen, avoid the damaging of direct contact of the legs, tissues, and other systems. So overalls, we could use lab coats. Disposable overalls should be used. It will fully cover the skin of the human body. So direct contact of fluids with this human body bare skin will be protected by using this lab coats or disposable overalls. So all the very simple, all the parts of the body must be protected from non-insulated pipes or vessels. So whenever we are dealing with a Dever vessel or non-insulated piping vessel or system or the closed container or vessels storing the fluid or transferring the fluid, we should protect the across the entire body. Parts of the body has to be protected properly. So other than that, so we got to train the skill labors. Skill training is very important. The few interns and staffs, the newly appointed staffs and labors should be trained properly with having standard operating procedure, SOPs, and safety measures and possible hazards. That has to be training is very important. So only training and qualified personnel only allowed to handle or transporting or storing these gases. Filling of cryogenic containers to be avoided. Don't fill the fluids, overfill the fluids. You have to provide with respective available required amount of system only has to be accommodated into the container. Overfilling is not allowable. It's not acceptable. It will lead to sudden pressure rise as well as explosion kind of thing. Apart from this, slow pouring of transferring gravity is preferred. Slowly we want to pouring the fluid as well as we want to transferring the fluid in a slow manner. That also preferable. So it minimizes boiling and splashing. on the skin or eyes or hands or legs or any parts of the human body. All system vents must be directed away from the personal or decent work areas. We should provide the venting or whatever may be. Ventilation should be provided that will be not directly from the personal. It should be designated in such a way it should be away from the working areas. So other than this covering or protecting device systems, covering device systems, we would provide other devices to controlling the system or like allowing and other kind of thing. The first one is oxygen detectors. So we are discussing on the deficiency or enrichment of oxygen is also one of the important aspects of safety in cryogenic fluids. So that oxygen availability detection detectors are very important. We can provide oxygen detectors. It can be used to provide the level of oxygen available in the range of 0 to 20%. The detectors will operate in the range of that way. You can use it. The pressure relief, the second object, the relief sudden pressure rise can be controlled or ventilation by using a pressure relief valve. It's a device which can be used to control the or limiting the pressure in a closed vessel. Or you can use a bursting disc or duster disc. A bursting or after disc can be used a non-self-closing pressure relief valve. It is a kind of aging disc. Unlike pressure relief valve, it is used to vent the entire system to atmosphere. During excessive pressurization as well as excessive vacuum condition, these bursting discs can be operated not like pressure relief valve. Pressure relief valve can be operated only in excessive pressure condition, but this bursting disc or the vector disc will be useful when the entire system to atmosphere in both excess pressure as well as excess vacuum conditions. So these are all the other than as I mentioned earlier, we can provide vending holes. Alarming system can be provided. Flashing light, blue rotating blue light can be provided to alarming us whenever there is a possibility of sudden pressurized. So other thing are the different various safety kind of assaults as well as the protection of these systems. So once again, I'm repeating, explaining, summarizing the system. So cryogenic fluids are very much deal with the very extreme low temperature, storing, transporting, and handling. Both three areas are very important. So whenever deals by a skilled laborers, human being, there are possible lot of hazards can occur. They are like extreme or cold or low temperature hazard, direct reaction of the hazard on the human body, any kind of body system, eyes, the tissues, whatever, wherever maybe it can be react. Second one is the fire hazards. Third one is the explosion. Both are with respect to excessive burning, so excessive the boil off, and excess pressure conditions, and no proper ventilation availability. All are the reason for this fire and explosion kind of thing. If it is not properly containers, not closed containers, not properly managed the pressure conditions, or overfilling of this fluid in the container or vessel, that all will lead to explosion and fire hazards. And also deficiency and enrichment both are very important. Deficiency tends to have a breathing problem of whatever maybe we can achieve. As well it can pressurize variation or also lead to the system whenever it is replaced by other gases like helium, hydrogen, and argon, neon, and all. That is also causes some uh, assaults with the system of human body and other operating conditions. It's system of fluid and transferring and as well as transporting and maintaining the system. So enrichment also oxygen also one of the reason for taking hazards. And the last one is the ductile and brittle nature of the material. Whenever using the cryogenic fluid storage and handling, it tends to forming the rupture or structural damages, breakaging or the leakaging of the system. That is also one of the important hazards. How to protect it? Normally by providing a normal protecting system like gloves, shoes, overall cloth, coats, lab coats, skilled laborers, trained laborers, and controlled flow handling of the fluids, controlled handling of the transportation of the fluid, controlled storing of the fluid, close container provision of ventilation, and rooms and other thing and sealing everywhere so that the control can be hazardous can be controlled. Apart from that, we can use some devices like splash light and blue light, rotating blue lights, alarming systems, pressure relief valve, oxygen detectors, bursting disk or up to disk. All those things devices can be used controlling the pressure as well, alarming the availability of the gases and deficiency of oxygen and other systems, level of oxygen, everything can be, all the hazards can be controlled. These are all about the various uh, hazards or safety aspects, the cryogenic fuel storing and transportation and handling, and how to protect it, the safety measurements protecting these hazards. So, if you have any doubt on this topic, you feel free to ask.